Welcome back, everyone. If you had pets and you gave them some love, I hope they enjoyed it, and I hope you enjoyed it too. We are now entering the second thematic track of the program, the Green Track, which is powered by Frost & Sullivan. And to open the session, our keynote speaker will highlight market developments in both water and buildings industry, such as the evolution of the digital twin and building information modeling platforms in the construction industry, as well as important driving and restraining factors that influence market growth, top predictions, latest trends, and market management at a global and regional level. Ladies and gentlemen, here is Frost & Sullivan's APAC Director of Environment and Building Technologies, Mr. Melvin Leong.
Hello everyone, my name is Melvin Leong from Frost & Sullivan. Now, first of all, I would like to thank you for joining us today, and I hope that all of you remain safe and healthy. Well, in this session, I will let you know the key trends related to digitalization in the water and buildings industry, in particular, digital twin solutions, and some other applications related to it. The underlying key message in this session will also touch on some sustainability factors that drive the adoption of digital twin. By now, we have already felt the effect of COVID-19. So markets are severely impacted, and it can be positive, like healthcare, or negative, like tourism and airlines business. And of course, there are businesses that are focused to undergo change, like education and energy. The healthcare segment was perhaps the busiest market in the past few months, from hospital operations to healthcare supplies. We use hand sanitizers more than ever before, and this leads to greater demand for chemicals. The not so good news is that the buildings industry is generally slowing down. And although the water industry remains an essential sector, overall new investments are delayed or deferred. Now, in the midst of all this chaos, there are specific trends and opportunities for digitalization in the water and buildings industry. We will understand why and how it is so with the strategic imperatives next. Now, there are three strategic imperatives that drive digitalization in the global water and building industries. The first is disruptive technologies. There are many technologies such as AI, machine learning, IoT sensors, building information modeling or BIM, and geographic information systems or GIS. Now, these can be used for data-driven decision-making, detection, predictive maintenance, what-if scenario analysis, and asset optimization. The next imperative is innovative business models. Technologies are not easy to afford and maintain. The COVID-19 pandemic has brought enormous financial pressure on governments and the private sector. And that is why we need new investment and payment models to encourage ownership of advanced technologies. And the last but not least, the imperative is industry convergence. No industries are developing in silos now, and especially for digital twin platform, collaboration will be required, and it is important from stakeholders or experts in IoT, SCADA, BIM, and GIS. But of course, challenges will always be there that slows down digital transformation. And these are very common challenges that companies need to overcome. Financial concern is one of the challenges. It is a common perception that technology cost is high. Now, data quality issues. Sometimes it is not about insufficient data. Too much data can be complicating. And this can be overcome with reliable analytics and digital platforms. Now, users are also concerned with cybersecurity issues. Can their data be protected? This question is very true when confidential information of businesses are at stake. And of course, there are infrastructure challenges in retrofitting advanced platforms, especially in facilities that are quite old. The lack of talents and professionals in supporting advanced digital platform is also slowing down adoption. Now, the overall AI readiness, especially by the government sector, influences the speed of digital transformation in the rest of the country. And last but not least, many businesses maintain a culture that does not recognize the need or importance of going digital. Now, before we go on about digital twin in the water industry, Frost & Sullivan has developed an indicator, and we call it Digital Water Index, or DWI. It indicates the sustainability level of a country's water infrastructure and the adoption of transformative technologies such as AI, IoT, and cloud. The DWI is a combination of two indexes, the water index and the technology index. Now, we are not going into those details here, but let's look at how we have plotted 21 countries globally, as shown here. Only 4 countries from Asia Pacific seem to have fared better, which are Singapore, Australia, Japan, and South Korea. Now, as you can see, Singapore and Australia are at the forefront, and they are what we call as front runners in digital water. Now, these countries should be an immediate focus for digital solution providers. Countries that are in blue are followers, and it means that these countries are sporadically adopting digital technologies in this water industry. Now, the rest of the countries in gray are categorized as starters, and these are the long-term opportunity countries for digital water development. Now, these starter countries would present great investment potential for the digital water participants in the next 5 to 10 years. So, what is digital twin, that you may ask? Simply said, it is a digital replica of an object, such as a water treatment plant, or items such as buildings or the entire city. So this digital twin technology can be used to replicate processes, and data are used to predict how these processes will perform. So in essence, it creates simulations of water treatment plants in this case, and predicts how infrastructure or process will perform, including water source trends. Now, as defined by Smart Water Networks, or SWAN, digital twin technology in a water treatment plant collects information from existing automation and monitoring systems. They integrate the vast data, analyze them in data-driven models or physics-based models, and finally perform visualization of the water treatment plant. Now, essentially, digital twin creates an enhanced operational experience for water utilities with real-time performance dashboards, advanced automation, and many more. Now, the overall goal of digital twin is really to create a secure and connected water utility, inform decisions, optimize plant performance, and actionable results. Now, to further understand the functions of digital twin technology, it operates with 5 work pillars, which is physical asset data, field data of plant, asset performance data, analytics, and lastly, visualization. Now, these 5 work pillars of digital twin will lead to 3 things that are informed decision, actionable intelligence, and optimized plant performance. And the final outcome with the use of digital twin technology for water utilities are energy cost savings, carbon savings, and increased productivity with reduced maintenance. Now, as shown in the current slide, billions of dollars can be saved with the use of digital twin technology in water treatment plants. Now, the benefits are up to 30% savings in the outcome that I've just mentioned, which are energy savings, carbon savings, and productivity and maintenance. Now, depending on how the technology is being used and also challenges of each water utility, those multiple savings that I have mentioned can lead to OPEC savings of tens of billions of dollars a year. And that is a lot of money to be saved for future and new investments and improvements such as replacement of distribution pipes and water source protection. Now, our research shows that the digital twin technology market in the global water industry is worth $416 million in 2019. And given the unforeseen circumstances of the COVID-19 pandemic, the growth would decline to 21.7% in 2020 from 38.6% in 2019. Now, which in my opinion, it is still a fairly good growth rate for the market. Now, moving forward, this technology is expected to gain momentum in the global water industry. And we have forecasted the market to reach to almost $2.9 billion by 2026. And that is a CAGR of above 30% from 2019 to 2026. Now, digital twin solution providers and also water utilities must understand that the fundamental growth opportunity is based on the three core values mentioned earlier, which are energy cost savings, carbon savings, and productivity and maintenance savings. Now, another potential growth opportunity for digital twin solution providers is smart city development in the future. Now, these companies need to target upcoming smart city projects, and these projects usually emphasize sustainability theme solutions as top priority. Now, this slide shows some of the many technology providers, and we can see some familiar names that are already present in the water industry and the business world for decades. Now, the list here shows a mix of new and incumbent players in the water industry. Xylem, Innovice, Black & Veatch, Siemens, Trimble, Veolia, Suez, and EnviroSuite are some companies with digital twin solutions. Now, most of their projects are with water utilities in Europe, North America, and Australia. Now, to say that the market is competitive, now it is not quite true because most of the solutions available in the market are quite unique or niche. We believe that there is no one single solution that has been adopted utility-wide or at the level of the entire water network. Solutions right now are mostly focused on asset improvements to increase operations efficiency and energy savings. Now, the issues such as water loss, distribution efficiency, water consumption, and even water source pollution are very unique challenges by location and culture. We would say that there is no one solution that fits all, but the opportunity is on how digital twin technology can be designed and customized to suit the needs of any water utility. So before we continue with the buildings industry, let's have a look at how we have mapped country markets in the digitalization level in construction. Now, we have mapped key country markets globally, and we are showing the Asian market here for today's presentation. Now, with relative comparison, advanced economies like Japan has very high digital adoption rate, and therefore its overall pace is considered mature. Many key APAC economies fall in the middle rung of the digital pace, such as Indonesia and Thailand. And only countries like Australia, Singapore, and South Korea is placed higher in adoption of digital construction solutions. Now, closer to home, Malaysia scores better in digital construction adoption and overall pace when compared to many other Southeast Asian countries like the Philippines, Indonesia, and Thailand. Asia's largest economy, China, has very accelerated pace of digitalization, and adoption-wise, it is also mapped moderately in the construction industry. Now, technology-wise, there are so many digital technologies that have been widely adopted in construction. Now, all of us might remember 2D and 3D computer-aided design software, and they have been around for ages. Now, today, these two technologies are considered mature or established, but have started to show lesser impact to the advancement of construction. Now, in today's world of construction, they are already exposed to many emerging technologies such as AI and machine learning, 3D printing, digital twin, augmented reality, laser scanning, big data analytics, drones, and robotics. Now, these technologies give positive impact to the construction industry in terms of operational efficiency and, of course, the overall accuracy of processes. Now, of course, adoption of these technologies vary by country and type of construction, and also depends on technology availability. Now, at the same time, established technologies such as cloud, BIM, and mobile mapping system are already in place in the construction industry, and these technologies will continue to be developed together with the construction practices. Now, in the next few slides, we are going to learn a bit on how an emerging technology like digital twin works hand in hand with BIM, which is an established technology. Now, I'm sure many of you would have heard about automated buildings or smart buildings. Now, these are past concepts. The fact is that the adoption of AI has been around since the 1980s. But application is actually very limited to basic automation of a building, or what we call as assisted intelligence. Now, an example would be automatic doors, assisted by basic sensor technologies. Now, in the past 20 years, smart buildings were trending. Actually, today it is still trending because it helps in managing and augment intelligence on one very important key aspect, which is energy management. It is an era of machine learning whereby lighting and air conditioning systems become smart and they communicate with one another. Now, the future of buildings will be based on cognitive buildings, which is really an extension of buildings being smart. And the difference is that cognitive buildings enable deep learning in its occupant behavior, including occupancy rates and occupant movements. And it has autonomous intelligence whereby decisions are made with very little or no human interference. Of course, the concept of cognitive building has started with the adoption of digital twin platforms that are AI powered and supported by established technologies like BIM. Now, if we look at the evolution of technologies adoption in the buildings industry, you will understand how digital twin and BIM are going to support the development of cognitive building in the future. Now, most of us would know that 2D and 3D CAD models are highly siloed processes that focus only on built environment design and have very little transition to third-party software. BIM has eased the transition to third-party software with its ability to host a database of building and built environment data. Therefore, it is actually widely used in the design and construction processes today. Now, however, we must understand that BIM is a 3D static model, and there is still lack of stakeholder integration. Now, when BIM is combined with digital twin, a 3D static model will become a dynamic model. And the visualization of digital twin will enable real-time building lifecycle management from design to construction and to operations. When we use them, BIM and digital twin, in a green building, this digital twin and BIM combination can help achieve sustainability targets as well. Now, the future is going to be exciting with these technologies, as it will transform smart buildings into cognitive buildings in that sense. Now, fundamentally, this will make energy and green performance of a building even more easy and seamless in the future. Now, in general, digital twin and BIM have already contributed to several smart and cognitive applications. Now, I'm quite certain that by now you might have heard about virtual voice assistants, predictive maintenance, performance optimization, and asset improvement. Now, these four applications are high-value opportunities with the use of AI-powered digital twin and BIM. Now, other applications that have lower market readiness but have some level of potential in the future are building process optimization and AI-based demand response and power trading. Other applications that are only emerging right now and might bring more important values in the future are AI-based home energy monitoring and lighting control, and home and social robots. Now, these applications will be supported by the values created with the use of digital twin and BIM technologies. Now, the values are operational efficiency, occupant comfort, and sustainability goals such as energy savings and carbon savings. Now, the idea from this slide also points to the importance of industry convergence, and that involves not only digital technologists and building players, but also electronics players and energy companies. Now, BIM and digital twin is a fast-growing and technology-driven market. Now, this year, like any other market, it is also facing an impact of COVID-19. However, BIM and digital twin companies are relatively resilient because of their cloud-based offerings and subscription-based revenue model. The construction industry itself is generally facing an uphill task this year, as growth is expected to reduce by nearly 90%, with very few greenfield projects to resume. Now, as a matter of fact, BIM and digital twin companies should focus on brownfield projects in the short term, especially in critical infrastructures of healthcare, pharmaceutical, food and beverage, utilities, oil and gas, and data centers. Now, during the time of adversity, opportunities arise in the area of net zero buildings, whereby BIM and digital twin will play an important role. Now, generally, sustainability goals will remain as a key agenda in the buildings industry and also for many governments globally. Now, these opportunities will lead to the BIM and digital twin market to reach more than $13 billion by 2026, growing at a CAGR of 14.5%. So, in the nutshell, there are four main key takeaways from today's presentation. Now, COVID-19 has certainly pushed digital transformation to another level and has forced many industries, not just water and buildings, to rethink about their strategies with the use of digital technologies. Now, the main priorities of any businesses, including building owners and water utilities, is OPEX reduction and operational efficiency. Now, BIM and digital twin will enable sustainable construction and operations of facilities. Now, one of the main goals of any built environment is to reduce energy consumption and achieve better environmental performance. AI and machine learning will be the backbone of BIM and digital twin platforms. Now, it is an important aspect for real-time virtual simulation of water and building assets. Last but not least, growth opportunities for BIM and digital twin players will definitely be the focus on key countries that have good prospects in the water and buildings industry, and also countries that have strong push for digitalization investments and commitment to sustainability and circular economy. Now, with that, I thank you for going through this presentation with me. Please feel free to let us know if you have questions on the presentation topic, and I will try my best to address them. So thank you once again, and I wish you to be safe and healthy and a happy and COVID-free 2021 for all of us in advance. Thank you.
All right, Melvin. So you have two questions actually, but before that, I just wanted to. I'm kind of interested in this idea of. So you mentioned that with BIM, with the twin technology, can create dynamic models for housing areas, right? And you also talked about how there's going to be an issue in terms of the market. The development market, right? The housing development, property development markets. So my question is kind of the growth rates and everything is one thing, but in terms of the motivation for our property development companies to adopt this kind of technology. So I think like that's something that I was quite a little bit interested in. What is your take on it?
Well, first of all, I think that is not a new question. I think I was asked by property developers, especially the ones here in Malaysia before, about the adoption of such advanced technologies in their property development projects. Well, first of all, we must understand that BIM is more applicable in the design phase and also the construction phase in today's construction activities. But when you combine with digital twin, you take BIM together with into a whole new level, into the life cycle or the operations of the building, and in this case, the properties, whether it is a commercial property or a residential property. So the aspect of operations really deals with the operational expenditure or OPEX that we have mentioned. So it really depends on the uptake in the public, whether the buyers, especially that you have mentioned, residential properties. Are the buyers ready to take or to buy these kind of properties that has advanced technologies? And usually, the price tag that comes along with the use of advanced technologies is not going to be right away affordable. Now the concept and this challenge here is really about how these technologies are going to be adopted with suitable payment models, or I would say ownership models, presented by the technology providers to the property developers or to the end owners of the properties. So the owners is really depending on the available benefits, such as incentives of owning or buying such properties, the incentive for building such properties using advanced technologies. So it really depends on the overall environment, governmental climate, I would say, incentives of funding or push given by the local government.
Yeah, that's a good point as well. And I think you mentioned the prioritization of development and adaptation of this technology to the healthcare industry. So I think that's interesting, right? If you can have cognitive buildings that understand the movements of the patients, and can understand the people going, the preferences, that would really, I think, make, really be an improvement to our health industry. Like the idea of that really, really does, spark something in me, what other, personally, what do you think, are exciting ways in which we can also use this technology?
In the healthcare industry, I assume, or elsewhere. In the healthcare industry, right. So basically, first we must understand, if you are going to use all these advanced technologies like BIM or digital twin in a hospital, for example, it really depends on, you must understand how a hospital functions. What is it for? Obviously, it is to provide healthcare services to patients who needs it or people who needs it. Now, as I've mentioned, to understand how a hospital work is really just beyond energy management, lighting controls, or people or patients' movement in a hospital. It also boils down into other aspect of a hospital building, which is number one, the air quality controls. So it is beyond energy and carbon savings. There are certain aspects that a hospital would be different when they use digital twin compared to a manufacturing facility who are using digital twin. So the purposes are different. So understanding how the facility function is definitely going to be important, which is why earlier in my presentation, I did mention or presented about the need of customization, or how you design the solutions that fits to the need of the facility.
Yeah, I think it's exciting listening about this technology. It's very exciting to think about, in the ways that we can already adapt it in the water, in the building, industries, but also the implications of this kind of technology when taken and then, built upon would have onto our society. Like customization, it'll be different, obviously, for each industry. Definitely, I agree with you. But I feel like when we start, that kind of incentive to start and do it, I think there's a limitless kind of opportunities. Not limitless lah, obviously there's a timing aspect to it, but I think when we build onto it and we see all these exciting things, it'll be cool. It'll be cool. So we actually have more questions for you. So we have someone from WebEx, Mr. Victor. He asks, is there any readily available products or services now based on the technology introduced earlier for business and consumers?
Well, in the Malaysian context, digital twin is already here. It's just that we could not see it. And now, of course, the famous Pan-Borneo Highway, which is in Sarawak. So if we are not aware about it, it's okay because we are here in the Peninsular Malaysia. So in Sarawak, when they have started to design and construct the Pan-Borneo Highway, which is expected to complete next year. So I'm not too sure about the schedule right now because of the COVID-19 pandemic. But the design of that highway and the simulation of the future operations and maintenance of that highway, which is going to be more than 1,000 kilometers long by the end of all phases completed. Well, that is using actually digital twin in the kind of a simulation. And the other project that here in KL that we probably didn't know that use digital twin in the construction, design, construction, and operations is the MRTs. The new MRT, which is currently still under construction, the second or third phase, I'm not sure. But the first phase of the MRT, completed MRT in a few years ago, was actually using digital twin. So if you want to try I would say experience the seamlessness of operations, maybe you can try to, I would suggest, we can go and have a ride on MRTs. But I think, getting on a public transportation today is, a little of a challenge today. Yeah, thanks.
Well, it's good to know that we're using, efficient systems to build our MRTs. We also have another question from Soon, also from WebEx. Thank you all to our WebEx watchers today. You're very active. Okay, the question is, I can understand the digital twin concept, but how can digital twin technology be used in the building industry? And do you have any examples?
Well, in the Malaysian context, first of all, there is no one true case study in the buildings industry. So what I have mentioned just now for the previous answer was more on the construction or the infrastructure construction as a whole. So for buildings, to answer this question, for buildings, it is basically more on the operation cycle, much less on the design and construction. So digital twin, so for example, so for an architect and engineer to be looking at a design or a blueprint of a building before the beginning of construction, a digital twin technology will be used to simulate and visualize how the building is going to run, especially with the installations of lighting, air conditioning. In Malaysia, we need air conditioning, much less of heaters. So, with that, we can visualize what kind of lighting pattern or air movement pattern in the building would entail. Now, another area or aspect would be safety. In case of emergency evacuation or fire safety evacuation. So such simulations can only be done with a digital twin technology. Of course, there are some supporting softwares that we can use for simulations, but digital twin make it more direct and easy and to the point. Now, the only challenge here, I would say, just to add on to this question, is really about compliance with local building codes. So whether the use of digital twin in the construction phase of a building is going to be recognized by local authorities or even associations like like BEM, Board of Engineers Malaysia. I would say the endorsement is very important for the advancement of the use of this technology in Malaysia.
Thank you, Melvin. I think from listening to your presentation, this is a definitely very interesting use of technology, and it could potentially save us a lot of money as well as be more energy efficient. And I think that's really, really cool. Thank you so much, Melvin. Would you want to have some parting words before you go?
Well, not really. Happy 2021. And that's it. Be happy always.
That is the best thing that you could possibly say. Okay, I'm going to change my seat from here to over there. I'll see you in a bit.
Sure. Thank you.